All right, we have tangent theta times cosecant theta equals tangent theta. So let's think about this for a second. If you have x squared equals x, are you just going to divide by x to get x by itself? No, you're going to move it over. X squared minus x equals 0, then you're going to factor it out, right? And then you're going to set each equal to 0. So the same goes here. You want to move it over. Tangent theta cosecant theta minus tangent theta equals 0. Factor out a tangent. Tangent theta times cosecant theta minus 1 equals 0. And then set each one equal to 0. So tangent theta equals 0. And cosecant theta minus 1 equals 0. So we have tangent theta equals 0. So let's put these on here. 1, 0, 0, 1, negative 1, 0, whoops, 0, negative 1. So when is your tangent 0? Tangent is 0 when sine over cosine is 0. So y over x is 0. So theta equals 0 and pi, right? We're staying in our domain between 0 and 2 pi. So 0 works, right? It's included. 2 pi is not included, so I can't put 2 pi. So just here and here. Now, cosecant theta equals 1, which means the sine of theta equals 1 over 1. 1 over 1, which is just 1. So when is your sine 1? Well, it's just 1 right here at pi over 2. So my answer, theta equals 0, pi, and pi over 2. That's all you do there. All right, we have another one to factor, right? I see 4 things. 1, 2, 3, 4. If you have 4 factors, the way to factor them is to factor them by grouping. So I'm going to group them together. I don't like putting parentheses because I don't like to have it wrong. But I'm going to group these 2 together and these 2 together. So look and see what I have in common. Well, in the first set of 2, I have a 3 tangent squared. And I'm left with, that's theta. I'm left with a sine theta plus 2. And then the second group, I can pull out a negative 1, and I'm left with sine theta plus 2. So I have sine theta plus 2 times 3 tangent squared theta minus 1 equals 0. Set each factor equal to 0. So sine theta plus 2 equals 0 means your sine of theta equals negative 2. Think about that. That can't ever happen, right? Because you can't have this number bigger than 1 or less than negative 1. So it's less than negative 1 right here. So this one is not going to happen. 3 tangent squared theta minus 1 equals 0. So tangent squared theta equals 1/3. So tangent theta equals plus or minus the square root of 1/3, which is plus or minus 1 over root 3. All right, so we need to think about our unit circle. Okay, let's look at this. It just says solve the equation. It doesn't have any restrictions, so we need to tell everywhere that it happens, right? So on the unit circle, tangent is plus or minus root 3 right here, and right here, and right here, and right here. So all the pi over 6's. So my answer is going to be pi over 6 plus, to get to this one, we're going to add pi k. And then we have right here is 5 pi over 6. And to get to that one is pi k. So 5 pi over 6 plus pi k. So those are all of my solutions for tangent. All right, solving multiple angle equations. So we have a formula, right, for the double angle. we know that formula because we memorized it. Sine of 2 theta equals 2 sine theta cosine theta. So we have two choices on how we're going to solve this. You can either use that formula, so sine of 2 theta, which is negative root 3 over 2, equals, so negative root 3 over 2 equals 2 sine theta cosine theta. Or we can use substitution. Now, funny story. Last year, Mr. Blackburn made these notes, and we had this problem on here, and we didn't really talk about the notes, and this last year was my first year teaching this. And he said to, so the note said there are two ways to approach this problem, and I was like, okay, well, I'm going to do these. So we get to this one, and there is some major math that has to go on in order to solve this equation. I think, oop, moved it. Whoa, hold on. I don't know what just happened. There we go. To solve this equation, that's so messy. There's some major algebra that has to go on. I'm going to make a separate video for that because I think it's so funny that I had to actually do this because I didn't realize he meant that as we look at that and think that's too hard to solve. So, Mr. Blackburn, I can do this one, but we don't want to do this one. So, you could use the double angle formula, but this is terrible to solve, and you guys will see if y'all watch my last video. I'm going to do it for you just for fun. But otherwise, use substitution. So if I say let u equal to theta, so now I have the sine of u equals negative root 3 over 2, right? So then thinking about where that happens, sine is negative root 3 over 2 in the third and the fourth quadrants. It's this one and this one. So I'm going to say that u equals, what is that, over 3? So 4 pi over 3 plus 2 pi k. Or it equals 5 pi over 3 plus 2 pi k. So we have two little equations for u. Now we have to substitute this back in. So I'm going to say that 2 theta, right, that's what u equals. 2 theta equals 4 pi over 3 plus 2 pi k. Now when you solve this and you divide by 2, because we're trying to solve for theta, we want it by itself, dividing by 2 is the same as multiplying times a half. Sometimes that's easier when you have fractions. I'm going to multiply everything times a half. So that's gone. I get theta equals 4 pi over 6 plus pi k, which can be reduced to 2 pi over 3 plus pi k. So there's one of my answers. I'm going to do it again. 2 theta equals 5 pi over 3, oh, that was a kid, plus 2 pi k. Multiply everything times a half. And I get theta equals 5 pi over 6 plus pi k. So those are my answers. Now, I promise I'll do the other one on another video, and it's going to be really a big mess. But if you guys like math like I do, and you like to deal with messes, then that video will be for you. So we are on to our last one. As I showed you, well, I haven't showed you yet, but as I told you on the last one that we just did, that it's hard to do using the double angle formulas. Obviously, if you have a 3 theta, it's going to be really hard to use a double angle formula and an addition formula. So we're definitely going to let u equal 3 theta. So let u equal 3 theta. You have 2 cosine u plus 1 equals 0. So cosine u equals negative 1/2. Your cosine is negative 1/2, so let's look at this at 2 pi over 3 and 4 pi over 3. So u equals 2 pi over 3 plus 2 pi k and 4 pi over 3 plus 2 pi k. Now, I know that it has a domain restriction of 0 to 2 pi, but because I have this triple angle right here, I have to go ahead and add the 2 pi k. And just like we did before, when you divide by the 3, when we're substituting back in for the u, we have to divide everything by 3 and then see where all that happens in between 0 and 2 pi. So I'll show you, it'll make sense. So we have 3 theta equals 2 pi over 3 plus 2 pi k. So when I multiply it by a third, right, to get rid of that 3 theta, multiply all this by a third, I have theta equals 2 pi over 9 plus 2 pi over 3k. So if you think about that, 2 pi over 9 plus 2/3 pi is not going to be bigger than 2 pi, right? So if I put this one with a common denominator of 9, I have 2 pi over 9 plus 6 pi over 9 times k. So we need to write down, even though we have this domain restriction over here for our theta, we need to answer it with every time that happens, the 2 pi over 9 plus 6 pi over 9 within that 2 pi. So we need it to be less than 18 pi over 9. So my answers for this one are 2 pi over 9. Then if I add 6 pi, we have 8 pi over 9. That's still okay. Add another 6 pi, 8 and 6 is 14 pi over 9. Sorry. And then, I guess I can move that so we have more room. And then add another 6, that's going to be 20 pi over 9. So that's too big. So these 3 are solutions. So now we need to do it again with our other solutions. So 3 theta equals 4 pi over 3 plus 2 pi k. Multiply it times a third. Multiply this one times a third. And you get theta equals 4 pi over 9 plus 2 pi over 3. That's not a k. Times k. So let's see where all that happens. So we have 4 pi over 9. Here, I'm going to erase this box so I can keep it going. All right, we have 4 pi over 9. This is 6 pi over 9. 6 pi over 9. So 4 plus 6 is 10 pi over 9. Add another 6, you get 16 pi over 9. And then obviously if we add another one, that's going to be too many. So all of our solutions are right here. So we'll talk more about that in class. I'll go over it. And now I'm going to stop this video and I'm going to do one more with the crazy math wizardy that I do on that last problem.